Now, even though the topic says floating rate instruments, but we're also going to be covering money market instruments over here. And they are both different, right? So what is floating rate instruments? These are instruments with variable rather than fixed coupons, whereas your money market instruments are the ones with maturities of 1 year or less. So your variable rate, which is instead of having a fixed coupon, what you have is that coupon is linked to another benchmark rate, right? And your money market instruments are 3 months maturity, 6 months maturity, 9 months maturity, less than 1 year. So let's get started with the floating rate notes, and then once we complete our analysis of this, then we will move on to money market. Now, what is this reference interest rate that is the basis for your floating rate notes? It could be LIBOR, right? It could be the SOFR, which is the secured overnight funds rate, or the London interbank offer rate. And something I want to point out over here is that please don't mix floating rate notes with something called index linked bonds. They are two different things. First of all, let's try and understand practically why somebody would want to buy a floating rate note versus an index linked bond, and why either of them are more attractive than your normal fixed rate coupons or fixed rate or fixed coupon rate bonds, right? So let's say Amazon offers a fixed rate bond of 2% per annum, right? And at that time, let's say the interest rate is also close to 2%. Let's say the Federal Reserve is offering a rate of 1.9%. So you go for that fixed rate of 2% because it's higher than 1.9. But then what happens is that the Fed increases the rate, let's say to 2.5. Now you're stuck with the Amazon bond because it's at a fixed rate, right? So that's why instead of going for that fixed rate bond, what you could have done is gone for, let's say Apple, on the other hand, was offering a FRN, a floating rate note, and that was basically offering the Fed rate plus 0.1%. So the Fed rate at the time was 1.9 plus the 0.1 was giving you 2%. So at the time it was equal to the Amazon bond. But if you had gone for the Apple floating rate note, right, then when the Fed rate went up to 2.5 from 1.9, then you would have gotten 2.5 plus that 0.1, because that is basically what Apple is offering, a little bit additional to the Fed rate, and your return would have gone to 2.6, which is obviously more than the 2% at which you would have gotten stuck at if you had bought the Amazon bond. Now, these are just examples, obviously, but the point here is that this is the logic why somebody would want to go for a floating rate note instead of fixed rate bond if they think that the Federal Reserve or the central bank in their country, whatever is that reference rate, it could be LIBOR, it could be SOFR, it could be, let's say in the GCC, in a place like Dubai, you have the Emirates Interbank Offer Rate, and so on and so forth. In Europe, it's the European Central Bank which sets the rate. So whatever that rate is, the reference rate, if you expect it to go up, then you're better off buying a floating rate note than a fixed rate note. Now, let me just talk about index linked bonds before I move on into more details about floating rate notes. Now, index linked bonds are linked to something like a consumer price index, right? It could be linked to another index as well. But one example is a consumer price index, which is basically an index for inflation. Now, if inflation is going up, right, and let's say inflation has gone up to 4%, and whether you bought that Apple floating rate note or whether you bought that Amazon fixed rate, the point is they're both less than inflation. So you're very sad because the value of your money is going down because there's high inflation, and you're not multiplying your money faster than inflation or more than inflation. So in that situation, you would have probably been better off buying an index linked bond, which increases its coupon amount or coupon rate or interest payment rate basically as that index goes up. So this is the logic of buying the floating rate notes or index linked bonds, right? The point is to protect the investor from volatile interest rates, or in the case of your index linked bonds, to protect the investor from volatile inflation. So the reference rate, which we write as MRR or the market reference rate, could be various things. It could be the T-bill rate, right? It could be, like I said, LIBOR or the SOFR. And why more and more we are moving towards the SOFR and moving away from LIBOR is because of something called the LIBOR scandal. So if you're interested, you can look into that. And we are now moving more and more towards the secured overnight funds rate. But the really, really important point that I want to really emphasize on, let me draw a few stars over here, because I have seen a lot of students make mistakes because they forget this point that these payments are made in arrears. Now, what does that mean? See, when you go to a bank, let's say you go to a bank right now, you walk into a bank and you ask them, what is the interest rate you're offering? And they say, we're offering 4%, right? So, and let's say you put down $100 in the account and you're like, okay, I want this 4%. So let's say you put down the $100 right now. That 4% will be paid to you at the end of the year, right? So let's say this is Jan 2024. It will be in December 2024 that you will get that 4% in your account. But even though the rate was given to you at the beginning of the year. So what students get confused in is that when we tell them, or when the question tells them that, hey, this 4% is for this period, right? Or let's say if I tell you the rate, then the interest rate has gone up. In December of 2024, we find out that the interest rate has gone up to 5%. Now, what students would do is that, okay, they'll say, okay, 4% is the rate for Jan for 2024, right? And this is the 2024 year, and let's say this is the 2025 year, and 5% is the rate for 2025. And when they have to calculate the amount, they end up using the 2025 rate. Because, I mean, they just make that mistake, right? Because 5% is the 2025 rate and we have to calculate the 2025 interest. So they just say it's going to be 5%. Well, it's not going to be 5%. Because, again, with the bank example, the rate that is quoted to you is what you get after the period has passed, right? So this is paid at the end of the period, and this payment structure is called in arrears. It's paid in arrears. So please don't make that mistake. Right. So the reference rate is the benchmark, of course, like we were looking at corporate bonds, fixed bonds, right? Where you had your government bond and then your corporate bond offering a spread over the government bond. Similarly, even in the case of your floating rate note, right? Even in the case of your floating rate note, they offer the benchmark, the MRR, whatever that MRR is, plus the spread, right? They also offer a spread, or we call it a margin, a quoted margin, right? And it's very, very important to understand this. Why? Because see, remember this formula: present value is equal to the payment plus payment plus payment and plus future value, right? And this was divided by r, 1 plus r to the power 1, and then this was 1 plus r to the power 2, and then dot dot dot, and then this was 1 plus r to the power n, right? And this is payment n. So why is this so important? Is because, let's say, we're back with the Apple example, that Apple is offering your MRR plus 0.1%. And the MRR at the time was 1.9, and plus the 0.1% was giving you 2%. So Apple was offering 2%, and it said that, hey, I'll pay you that 2% of the face value, which at the time you calculated as $2. Let's say if the face value is 100, right? So $2, $2, and then the 100. And then this rate, assuming that this is what the market also required from it, could be 2%. Now what can change? Like what can happen going forward? This MRR could change, right? This could go up or down. But the spread or the quoted margin does not change. Once the instrument is issued, quoted margin does not change. It's fixed. Now, let's say the MRR goes up, right? It goes to 2.5%. Quoted margin doesn't change. So now the rate that Apple is going to pay is 2.6%. So all these payments go up. Because the benchmark rate has gone up. And depending on how the market feels about Apple as a company, maybe the discount rate is the same in the case of the spread, which means if the government is offering, let's say this is, if we're talking about it in terms of a fixed rate bond, if the government is offering 2.5%, then the market feels that a spread of 0.1 is sufficient for Apple based on the additional risk that they are taking by investing with Apple, right? So that means as the payment amount goes up, the discount rate also goes up to 2.6%, because the government, when it increased the rates, assuming that there is a shift. So the point is that if it stays the same, so the present value stays at par. But what can get tricky, and this is where I need you to pay attention, what can get tricky is what if Apple as a company became better or became worse. So let's say it was a A-rated company, it became better, it became a AA rated, or it became worse, it became a triple B. Then this quoted margin, which was the spread being offered over and on top of the benchmark, might not be enough, right? If the rating goes down, the 0.1 quoted margin is not going to be enough, because people will see, oh, this is a more risky company. We want a higher premium. We want a higher margin. We want a higher default risk premium on top of the benchmark, right? Which means even though the payment amount will not change, because the quoted margin does not change, and the payment is calculated based on the benchmark plus the quoted margin multiplied by the face value, but the discount rate will change. The people will require a higher rate, and the discount rate will definitely go up. And if the discount rate goes up, right, the present value comes down. And this is what you have to appreciate, that with the reference rate going up or down makes no impact on the price of this instrument, right? So why is all of this important is because that spread that they are offering, that quoted margin that they are offering, is linked to the credit quality of the issuer, right? So the benchmark rate can go up and down. It's not going to impact the value of the bond because the payment is also going to go up and down. The payment will be going up and down with it. The discount rate will be going up and down with it. So it nullifies the effect. What's really dangerous is that this is fixed. This does not change. The quoted margin does not change. But the discount rate can change if the investors require a higher discount because the risk goes up, if the credit quality deteriorates. And that is where the present value is going to go down if the discount rate goes up. Because the quoted margin is not going to change, so the payment will be fixed. And if the discount rate goes up, well, the present value will go down. And this is the key point that you need to pick up over here. Let me show you with an example. But first, let's compare two bonds just to understand that why one has a higher quoted margin than the other. It's definitely linked to its credit risk. So let's compare Nationwide, it's UK's largest building society, credit rating of A2 versus Apple, credit rating of AAA. Obviously, AAA is better than A2. AAA minus, but you get the point, right? Or is it just a hyphen? Either way, it's definitely much better than A2. So UK's largest building society, Nationwide issued perpetual floating rate bond. Perpetual means that it has no maturity. It's just going to go on forever. Floating rate bond with a coupon rate of 6-month MRR plus 240 basis points or 2.5% quoted margin. That's a significant margin, right? That's a significant margin. And why? Because it's a reflection of its credit quality. Now, Apple, on the other hand, is only offering a 5 basis point or a 0.05% margin because its credit risk is low, right? So there you go. Obviously, I mean, it's a 6-month versus a 3-month, but the rates are quoted on an annual basis. They're applied. So when you'll apply the rate to calculate the payment amount, of course, we will do it for a quarterly basis for Apple and on a semi-annual basis for this Nationwide, which means we'll divide this by 2 and we'll divide this by 4 when calculating the quarter or the semi-annual rate. But the point is that the rates are quoted on an annual basis. So these guys are offering 240 basis extra and these guys are offering only 5 basis point extra. So clearly there is a big difference here, and that is because of the difference in credit rating. Now, the required margin can be different from the quoted margin, right? And if that happens, then if, let's say, the required margin increases because there is a downgrade of the credit quality, well, then the price will go down because it's as simple as the payment staying the same because that is linked to the quoted margin. Payment is calculated based on the quoted margin, but the discount rate you are using is based on the required rate or the required margin. And if the required margin goes up, please excuse this very bad handwriting, required margin, if that goes up, well, your present value is going to come down. And let's have a better formula over here. So the payment is staying the same because of the quoted margin. It does not change. Whereas this R is dependent on the required margin, and that can go up if there is a downgrade in the credit rating, and then the present value will go down. Right, so for example, a floater has a coupon rate of 3-month MRR plus 50 basis points. 6 months after the issue, the credit rating is downgraded. Market requires a 75 basis point more than the 50. So the market obviously demands more. What the coupon is offering is lesser, and therefore the price will go down to par. So if it was issued at 100, it'll probably start trading at something below 100. And how much below? Well, that depends on how much the present value will fall, right? Based on all these payments, it's gonna depend on how much the present value will fall, depending on how much the discount rate rises. Right, so let's bring it all together. If the required margin and the quoted margin are the same, it will trade at par. If the required margin is greater, obviously it will trade at a discount. And if it's less, if the required margin is less, then your bond will be at a premium. Very, very simple. If this goes down, the present value goes up. Now, this can get a little complicated. Actually, it's very simple, but you have to just slow down and go through this with me. Now, let's take one thing at a time. Let's first calculate the payment. Now, how is this complicated looking formula getting us the payment? Let's take the example of our Apple bond, which was paying us MRR plus 0.1. So let's say the MRR is 1.9%, right? Quoted margin is 0.1%. Now that is obviously 2%, right? And then if this is for a full year, that's an annual coupon, then you just directly multiply it with the face value and you get the $2. If, however, it's, let's say, a semi-annual, then you divide it by 2. Well, you don't divide the 100 by 2. I mean, what you're actually doing is you take that rate of 2% and you divide that 2% by 2 and then multiply to 100, right? So that I mean, it should be written over here, but either way, it doesn't make a difference in calculation. Because what you're essentially doing is you're taking that rate, if it's a full year rate, and you want to make it a semi-annual, just divide it by 2 and then multiply it with the face value and you get the payment amount. Very, very straightforward. Now, let's talk about the denominator, the 1 plus R. So this is R. How? Well, it's going to be that MRR of 1.9 plus the 0.1. But here, instead of adding the 0.1, we are going to add to the MRR whatever is the discount margin, which depends on the credit rating. Right? This is the required margin or the discount margin, which is required by the investors based on whatever is the credit rating of the company. And that, of course, has to be adjusted for any kind of periodicity. So if it's semi-annual, then again, we'll divide that by 2, like we were doing in the case of the payment calculation. And that is your denominator. So it's fairly simple. But if you are confused a little bit, let me explain you again. Let's focus on explain it to you again. Let's focus on the numerator, right? This is the numerator. How is it being calculated? Well, it's your benchmark plus the quoted margin. And if it's annual, well, then no need to divide it by anything. It's just going to be divided by 1, so it doesn't really make a difference. But if it is semi-annual, then you will divide it by 2 and whatever. If it's quarterly, you'll be divided by 4 and then multiply it with the face value to get the payment. Right? And then the denominator, which is your 1 divided by R, is coming from your benchmark plus the discount rate divided by the periodicity plus 1. And then for the next period, you just have to do it square. So let me just go back and show you. Then it will be square and then eventually n. So this is how your calculation is done for the payment and the discount rate. Now, it's a very simple way of doing it because we keep it simple. First of all, we're using a 3360, right? The value is calculated on reset date, so there's no hassle of that accrued interest and the dirty price and the flat price and all that, right? And the same reference rate is used for the numerator and the denominator, so thank God for this simple model. Now let's apply it. And before you pause the video and try to do this, let me just help you out a little bit. I just want to put you on the right track with regards to the calculation of N, right? So this is a 3-month, which means this is quarterly, and you've got a 3-year bond. So your N is going to be 3 years into 4 quarters per year. So that comes to 12, right? This is the quoted margin. MRR is 1% for the 3-month. So this MRR is for 3-month, 1%, right? So I'll just request you now to pause the video and try to do it, and don't worry about getting it wrong. Obviously, I mean, just try to do it, and then I'll show you the answer. Okay, so obviously the first thing here is to get your head around that N, right? And that is 12. Now we need to then work out the interest rate, which is going to be your MRR plus the quoted margin. And again, this needs to be divided by 4 to get the quarterly one. And that will be then multiplied with your face value. Since the floater is priced at 99, so we'll assume the face value is going to be 100. So you multiply that with 100 and you get your payment amount. Your present value, of course, has to go in negative. Your payment is positive. Your future value or face value is positive. And then you compute for the interest rate, the yield, and that comes to 0.5237. And that has to be multiplied by 4 to bring it back to the year. And now since they asked you just for the discount margin, right? So what you will do is from that 2.09 minus the 1, and you will get the discount margin, right? So what basically has happened over here is that you know the present value, you calculated the payment based on the quoted margin. The payment is calculated based on the quoted margin. The yield you don't know, so this you calculated with your calculator, the I by Y. And once you know what is that yield which is making this payment and the subsequent payment and the future face value equal to this present value, then you know the yield. And all you have to do is minus from the yield the MRR, the benchmark rate, the reference rate, and that's it. You get your discount margin, right? So that's it, guys, for the floating rate notes. In the next video, we'll pick it up from here for the money market instruments.